Welcome to the A-420 PIC LabX Matrix Key Lab Part A. The first thing we need to do is go in Canvas and put our file folder on the desktop, the PIC Matrix Key folder that has our programs. Let's open up our MP LabX and start a new project. Okay, so let's go ahead and close out of our old folders and projects. And we're going to do new project. Standalone project, microchip embedded. Next. We're going to go to mid-range. And we're going to go down and pick a 16F877. Next, we're going to pick our ICD3. I already have one connected which has a serial number, so I'm going to select it. And XC8, so select that. And let's go to our folder that we put on our desktop, so we can put all our folders there and files. So we're going to go to PIC Matrix Key. There it is, PIC Matrix Key. Open. And we're going to call the first one PIC Matrix Key 1. Okay, finish. We're going to go to source files, right click, and we're going to go add existing item. Go to our desktop and find our folder. And we're going to pick Matrix Key 1. Alright, we're going to open up source files and we're going to double click on our matrix key. And everything should be good. So let's go ahead and run and compile it. And we're going to get our warning label, so let's OK that. And there we go. Program verify complete. So let's go take a look at it. Okay, so let's go through our Matrix Key 1 program. And again, we have all our configuration files here for our 877. We have our crystal frequency for 4 meg, which is our crystal, and it's going to help us with our timer. And we're using our XC8, and these are going to help us a little later. Here's our main, so we have all digital. Pull-up resistors for our matrix keys. And we're going to clear tri-state D and port D, which are driving our LEDs. And these two here are going to be our setup for our matrix key. So we have all ones, and here we have a 0 and a 0. So a tri-state's 0 is going to be out. So our port 0 is an output, and we're going to put a low. So all the other ports are inputs. And let me show you how that works on our schematic. Here I'm showing the schematic for a matrix keypad on our LabX. And I have set tri-state B0 to 0, which means output. So we're going to send an output through our switches. And we're going to make it a low. And we have tri-states B1, B2, and B3. I've set those to 1, which are inputs. In this case, they're going to act like an active high and block. So we're not going to read these, and we're not going to send any signals out to these other 2 rows. So we're only going to read row 1, switches 1, 2, 3, and 4. Here I've set tri-states 4, 5, and 6, and 7 to 1, which are inputs to the microprocessor. So what we're going to do is we're going to put a low out on row 1. I'm going to push a switch, and this pin is going to go low, and we know that switch 1 was pressed. When B5 goes low, switch 2 has been pressed, and 3 and 4 are the same. They're going to come out of B6 and B7. We have set our pull-up resistors to 1. So we have set up our pull-up resistors in the microcontroller to give us an active high, and we call that a weak pull-up, and these are going to be high unless we pull it low with one of our switches. So with this, we're going to use row 1, and we could read switch 1 through 4. Okay, back to our program. Now that we have our switches where we could read them, we are going to do a while 1. This is a continuous loop between these two braces. We're going to do a short 5 millisecond delay just to make sure everything is okay, settled. And if RB4, which is our switch 1, if we press it, it's going to go low. That means port D is going to light up LED 0. Okay, RD 0. Else, if RB5 is pressed, which is our 6-2, we're going to delay for 100 milliseconds, and we're going to light LED 2. Okay, that's going to be port D1, and it's going to flash and turn off. So we're going to cycle within this once we hold it down, and it's going to flash our number 2 LED. And if we push 6, we're going to light LED. This is a hex 4, so it's going to be LED 3. And if RB7 is pushed, we're going to get hex 8, which is equivalent to our LED 4. And if we don't push any buttons, it's going to shut everything off. And this just keeps it from erroring, keeps us from getting an error message, basically. So that is it. So let's take a look at our board. Okay, let's test it. First thing we need to do is pull our ICD3 cable out since it interferes with our switches. Push button 1, we light LED 1. Push switch 2, it flashes LED 2. Push 3, it's LED 3 on. And switch 4 is LED 4, and none of the other switches work. Perfect.